Howdy, we are Team 5, the 3D Occluded Object Detection System. My name is Hannah Hillhouse. We also have Tony Zhang, Samiha Alai, and Evan Poland, and our sponsor was Kevin Nauka. Basically, our project summary is the problem is manufacturers are using people to pick and place parts into bins for further use. This is not only costly to the company, but it's also not time efficient, and the results in a very cluttered workspace. So our solution is we'll create a 3D object detection system in which we'll localize and classify objects within parts bins and pick and place them into their corresponding bins for further use. We do that using 2 cameras attached to computers, as you will see in the demo, and they both hold the object classification model and the object localization code.
This is our integrated project diagram. Here you can see what the system is going to look like. We have 2 laptops which both have cameras. We have a 3D camera over a busy bin, and we're just using a web camera for a bin that's going to be organized. It's going to have much less pieces, just whatever was filled to order. On the 3D laptop, we have code for picking to order and handling occlusions. Like if an object is hidden, this is how we're going to find that object and classify it. And on it, it has a model made in YOLO v5. The same model is located on the 2D camera, but additionally it has error detection code, which makes sure at this point, now that the order has been received, I'm going to double check that I have in fact gotten the pieces that I said that I wanted. The error detection code, or the error detection checklist on the top right, you can see is outside of the code, and it is simply looking for, if we run into this error, what are the steps that we take to solve it? So first, what's happening here is it's going through the first 15 frames without doing any detection because we were having problems with, as the camera started up, the image was blurry, but after it ran a bit, the image got clearer. And you can see here, Tony's highlighting the order list. It shows the piece and then the location. So we get our X and Y values followed by the depth. Um, and so we would be able to pass that information to a robotic arm, which would then go and pick those pieces out, put it in the proper bin. And Tony, can you show us the localization and classification? So we were looking for, what was it, 2 L pieces and 3 T pieces. So you can see it went through it and it found, our 2 L pieces and 3 T pieces. Now let's run an example where a piece is occluded. So again, first 15 frames, nothing's happening. And then so we get the list of things that we're looking for. So here it found 3 T pieces. It found 1 L piece. So we're still looking for an L, still looking for an I. We would take those out. So given a situation where there is occlusion, we have the numbers on screen, the physical position of where the object is, and then Tony's now going to show how he goes through and finds the objects.
So it's 7 inches and 7 inches. Here.
So he's now found one corner of the bounding box. He's now going to find the other corner. And normally a robotic arm would be doing this. However, we did not have access to the robotic arm, so we have to do it in person.
And the other corner is here. So we found this piece right here, the T. So we take it out.
And it would continue this process with every single piece until all of them are done. Again, we see like these are the pieces it was looking at, which lines up. T, a T, a T, and an L. So we should still be looking for 1 L and 1 I.
Which is here. Yeah, we got them correct.
Okay, cool. And then you see it says order complete. Last thing I want to show is if we just don't have a piece.
So it has found all 3 pieces. So I take them out. Enter.
So you can see
27. So I check them as you asked to.
here it on the bottom it says shake 0. That's how many times have we shaken the bin. We get the error. The desired piece was not found because we've found 3. We still want 27 more, so we haven't found them all. Solution is shake the bucket. Tony is shaken, and then
Here. Still couldn't find any, but the shake count went up. So we check one more time. Check count 2, but we still couldn't find it. One more time. It's 3. So it's now saying the part you're looking for is out of stock because there's no piece on the bucket.
All right, so we have the organized bin here. You can see that in the camera overlooking the bucket that there are 2 I's, 1 L, and 1 T. Once we run the detection code, it will take an image of the bucket, apply the object detection to it, so it will have the bounding boxes and the labels of the objects within it. Okay, so as you can see, using the camera, the video that you're seeing is what the camera is seeing. You have 1 T, 1 L, and 2 I shapes. So once we turn off the camera so we can run the object detection, you can look on my screen. I'll run the object detection code. What it's going to do is take an image of using the camera, put on the bounding boxes and the labels, and we'll look at what the output is. So it's saying we have 2 I's, 1 L, and 1 T, which is exactly right. So we'll put in 2 I's, 1 L, 1 T, runs the error detection, and then we'll go into where it detected for the image and saved it. And the image itself is showing the bounding boxes with the label and the accuracy. So here you can see that it's asking the user to input the total number of I-shape, L-shape, and T-shape PVC needed. We are just gonna put 4 I-shaped, 2 T-shape, and 2 4 I-shape, 2 L-shape, and 2 T-shape PVCs. And here you can see that the original bin had 2 I-shaped, 1 L-shape, and 1 T-shape PVC. Therefore, and we needed 4 I-shape, 2 L-shape, and 2 T-shape PVC. Therefore, 2 I-shapes are missing, 1 L-shape is missing, and 1 T-shape is missing. Therefore, to handle the error, 2 I-shape will be added to the current bin from the parts bin, and 1 L-shape and 1 T-shape will be added to the current bin from the parts bin.